Good afternoon. My name is Charles Jennings. I'm director of the Christian Regenhard Center for Emergency Response Studies here at John Jay College of Criminal Justice. And I'd like to welcome you to this, our second spring 2023 seminar on the subject of smart buildings. And for those of you who are new to the center, the Regenhard Center is named for Christian Regenhard, a probationary FDNY firefighter who died on 9/11. And we are focused on issues of first responder response to large and complex events, to include technologies, command and control, and policy issues. And for today's talk, we're very pleased to have Mariah Marks of Siemens. Siemens is a name known to most people in the industry. Mariah is very active in life safety industry, fire and life safety industry. She's been in the industry for over 25 years. She's been an account executive for Fire and Mass Notification Solutions, National Business Development Manager for Tier Construction. She's currently vice chair of the NEMA BSSB Fire, Life Safety, Security, and Emergency Communications section. She's a member of the SFPE, that's Society of Fire Protection Engineers, editorial board, and vice chair of the SFPE Foundation Board of Governors. She's a member of the Board of Visitors of the University of Maryland Department of Fire Protection Engineering. She's a past president of the DC, Maryland, and Virginia chapter of the Automatic Fire Alarm Association. And she's a graduate of Wellesley College. She's also a certified fire protection specialist and is a NICET 4. So Maria is very well placed to discuss these topics today, and so we're delighted to have her. We've done work related to this subject of smart buildings, automation, sensors. We have a working paper on the subject, and it certainly complements our work on situation awareness. And so with that, I will turn it over to you, Mariah, and take it away.
Thank you. Thank you for the opportunity to present. I would say a couple of items to start. This presentation is AIA approved and USGBC. So if you do need credits, please reach out to Charles and let him know. The other one is I am working remotely. I do have a few four-legged office assistants. Please ignore any background noise. They're fine. And with that, I am going to turn my camera off. I've had some bandwidth issues today. If you have any questions, please feel free to ask. I'd like this to be a little bit of a conversation. So, as we start looking at smart buildings, we're going to take a look at how do you do this? They are transitioning from something that's nice to something that we really need to have. It's a different approach when it comes to how the building is designed, installed, or built, and then maintained. So we're going to take a look at what the definition of a smart building is and its role in occupant health, safety, and welfare, gain a better understanding of some of the current challenges to design, construction, and maintenance of these buildings. We'll take a look at how technology is converging to play a factor in this data interconnected building system, how it benefits not only designers, contractors, facility managers, and occupants, but also first responders. And at the end, we'll take a look at some of the use cases and how they are proving out what you can do with these buildings. So with that, typically I ask how and what you think is a smart building. And the reason I do that to get people thinking about it is there's really no one definition across all of the building types and vertical markets. So think about the different occupancies. It used to be, we said, okay, it has broadband, and that makes it a smart building. But today, we are looking to leverage the data you get from all the disparate systems, all the sensors that are out there. How can this data be used for real-time analysis and response? You have interoperable systems, or whether they're integrated via an interface. Ultimately, the smart building delivers useful and consistent experience in addition to providing space and energy efficiency. It is a contributor to the success of stakeholders. You can see that we're expecting smart building technologies to grow over the next couple of years and to reach 2 billion by 2026. Another way to look at a smart building might be the triple bottom line. We're used to the bottom line. There's always, what is it going to cost me? What is it going to, how do I gain? Well, if you think about a smart building, I said there are so many uses. It impacts the people. So you have the impact on people, or the social aspect, the impact on profit, which is your financial aspect. And now let's bring in green, sustainability, or the environment. They need to have an increased value and provide environmentally friendly design that serves the users and the community. We expect our smart building to establish all three of these in tandem with one another. So why? Everybody always says, what's the disruption? What is causing it? Innovation tends to be gradual. It starts slowly and then gathers pace gradually, working by increments. So early years, we may be a little disappointed by the innovation. It's not going as fast as we want. We sometimes underestimate the impact of innovation in the long run and overestimate it in the short run. So you have to understand what some of the technological innovations are that we see these days. From autonomous devices, augmented analytics, now that we have the data, along with AI. AI's been in the news a lot recently. How is it being used? How is it being regulated? On the digital side, digital twin, we can create a digital representation of your building that allow you to run scenarios through it or see how the building is operated. Much less also an immersive experience. There's talk about how can we use VR or augmented reality to provide training, to provide data. Of course, you need the technology. You need, how do I move it? Blockchain is a distributed ledger type of information where you're tracking every single piece of data. You know who's changed it and when. Which bring a couple other things that go across the bottom of all of this. Quantum computing, the speed of computing is going up and the size of chips are going down, when you can find them, that is. Privacy and ethics. Just because we can, should we? And that's something to keep in mind. Just because you can get that information, is it relevant to the situation? Do we need to know it? And how are we protecting the data? So we'll look at a few things here. Mega trends. These are things that are affecting all of us. We're impacted by digitalization. We see data in everything. And in the next 2 years, they're expecting 163 zettabytes of data will be available globally. 1 zettabyte is a stack of books from here to Pluto and back. That's how much data will be available globally in the next 2 years. Keep an eye on demographic change as well. The number of people, as well as average life expectancy. And where do these people live? How are they accessing systems, buildings? We also have sustainability or climate change concerns. It's getting hotter. We're about to experience a couple of 80-degree days here in the Metro DC area this week. It's only April. That seems a little early to me, but globalization is another one that I'll touch on. It's been a bit of an impact over the last couple of years as we've looked at global supply chains and what has happened. However, globalization is still a key aspect in it. You have, world trade impacting your cost for energy and fuel. It hits the logistic companies. Think about your supply chain and where and how we manufacture parts and pieces, components for all of the disparate systems, not just fire alarm, but all of our systems. Our economy is global and is intertwined. This isn't going away. The other part that's a bit of a reminder is we're starting to think about the building again on how people use it and what their experience is. So this goes back, 100 years. Form follows function. The form of the building follows the function of the building. How am I using the building? What do people expect? We want our buildings to be healthy. We want to make sure that our staff is retained if it's an office building. Space is optimized. How do we use it? So a designer can think about this. This is a good rule of thumb to keep in mind. Typical building expenditure comparison across the entire life cycle. You look at design, construction, operations, and employees. If the cost of your employees is $1,000 times the cost of designing the building or space they'll occupy, and 100 times the amount of construction cost. So if you increase design and construction costs by 10% to mitigate a 1% improvement in staff wellness and retention, it's justifiable. Think about how those balance out. Just because you're cutting corners on the construction or the design, what are you doing on the back end? The other thing that is changing is how we access our systems. Our facility management is changing. We have a personnel shortage. Everybody is talking about it. Every industry is facing this. There are estimates that it'll be a 50% shortage in facility management by 2035. It's not only that, it's how we access and how we use the systems. You start with our boiler Bob on the left. He was out in the field. He was using tools. He was working on systems and going off intuition. Blockchain Beth, on the other hand, is looking at the digital tools, looking at the trends and the data to make the decisions. There's also a convergence of IT and OT as well. So she may not be as deeply intertwined into all of the mechanical systems, but she knows what the results are supposed to be and what to look for and where that's going to direct her. So there's a shift in how we are adapting to the building. There's a shift in how we are receiving our information. I suspect you may have heard the phrase, there's an app for that. Many of us are getting information via apps or notifications. We can send notifications for mass notification or emergency communication events. We can provide what we call Reno or remote notifications in the Siemens world as to the status of the systems. There's also an app that allows for remote access into the fire alarm system, which will let you test and inspect. It will let you also troubleshoot and understand what's going on. That kind of data could be key. Think about understanding or seeing that information before you get to the site. Now you know what's happening and how to respond. Any questions up till now? And I'm sorry, I don't see the chat, so I'm not sure if there are any in there.
Nothing in the chat yet, but please direct your questions in through the chat and we'll get them answered.
Okay, well, I'm going to go ahead and we're going to start breaking down and talking about some of the people who are involved with the building. You know, we're going to start first from the design phase, and that's the architect, because the architect sets the scope. They set the change. There's a challenge that they're facing right now with the 2030 challenge that is given them an opportunity to adopt, whether it's specific energy, fossil fuel, or emission targets for all new building developments and major renovations to be carbon neutral by 2030. Huge global participation in this challenge, and this is really where smart buildings tend to play a significant role. What there is also is the complexity in buildings that's caused by some of these technology advancements can add to a little bit more of an increase in liability and legal aggression, which means that sometimes the architect hands it off. So they may not have that part of the scope because they may say, oh, this really isn't in my wheelhouse. I need to hand it off. I need to hand it to an expert. And that expert may still be siloed within their individual division. So that's something to be aware of. You need to have that conversation and keep the design team talking across the disparate silos. One of the other challenges that they face, and this is probably the biggest one when it comes to smart buildings, is the why. And think about the space performance. I've already alluded to the form follows function philosophy, but the architect is responsible for the overall vision based on input from the client. So they need to understand how the client is going to use the building and optimize the space based on that use and on the budget. So that brings in a lot of flexibility, as well as opportunity for the architect. I mentioned silos. You know, we have our mechanical, electrical, fire protection, technology, and plumbing engineers. They're not always talking to each other. So understanding the interoperability is key, and especially as you start merging or integrating systems together or depending on data from different systems, you need to be able to be talking to each other. You know, a great example is smoke control. It's something we've been doing for years, but it's something that easily gets missed completely in specifications or provided twice if you have a mechanical and a fire protection engineer that aren't talking, or they may have gaps. So you need to find a way to break down those silos and ensure that these engineers are coordinating across the silos. The other part is staying up with technology. How can you stay up with technology? How do you manage to leverage current technology while also dealing with code adoption? What are there design tools that can help you? You know, one of the simplest ones is BIM or Revit, and yet that tends to stay 2-inch conduit or greater, which means you're looking at major systems or major risers. You're not taking it out to the floor, which is where most of the clash occurs. Collaboration, staffing, all of this is key for your mechanical and fire protection engineers. And again, they are also worried about budget or cost, along with schedule and the scope that they've been given by the architect. They may not have been given the full scope if the architect doesn't understand what integrations are necessary to meet the vision or even possible that could meet the vision. So we had an architect that did that and really did a great job. Your MEPT, fire protection, also did a great job. Everything's integrated. Your building has been designed. It's gone out for bid. Everything is set to be a smart building, what we want. Now we've got the construction process. So the general contractor, they still look at it as I'm going to the mechanical, I'm going to the electrical, I'm handling the building envelope. So it's understanding and challenging the traditional project procurement and delivery mechanisms. So this will be a huge part of it for them. You know, keep in mind, they are very concerned. They want to make sure that their building is safe through construction. They want to be free of liability or unusual liability. So risk and safety are big for your general contractor. Constructability is another one that's big for them to pay attention to. They start looking at something that's different than they've used before. You know, many of the current constructability tools don't properly address smart building technology. So they're going to have to think about that and be involved as part of the design process. We've got it built now. And now we are open. Your facility operation takes over. For them, with the current staff, huge change. Approximately 55% of maintenance activity is reactive. They're fixing something when it breaks. You know, they're saying, hey, my room is cold. That's what they're worried about. What if we have to change the mindset? So they start thinking predictive algorithm and start thinking about, let's get to it before it breaks. I mean, how many of you seen the commercial where the elevator dings as an elevator repairman is talking to the facilities security guard there at the building? Hi, I'm here to fix the elevator. Next thing you know, people are stepping out of the elevator and they're looking like, what's going on? Well, presumably what had happened was the elevator knew that it was using more energy, running a diagnostic check. Hey, I haven't changed this belt in how many runs of my elevator. It's good for X number of runs, needs to be changed. Let's send in a maintenance request before it breaks. Predictive analysis. So we're starting to see the capability for things like this. So start thinking about how you can use it. There's a new player. In the fire and security, in the fire world, we're not as used to working with IT or information technology. So this is brand new. If you're going to leverage interoperability and convergence, you need to bring the IT team into the picture. They need to be aware of it in order to be a part of the process and not introduce further complexity afterwards. Think of it from a holistic perspective as well. What are some of the things that they can do? Keeping in mind, when you start looking at OT, you have to keep uptime and business continuity in mind. The fire alarm system is still 100% uptime with battery backup. You're not taking it down to run a patch. And this has also started, you know, understanding, and the authority having jurisdiction, understanding the benefits of smart technology and why, and how we could use this. You know, a great example would be modular construction. That's used a lot within smart building projects. We have the capability of building sections, providing systems in there. For example, a zone control unit. It gives and we can do this beforehand and then get it on site so that you've minimized your construction time frame while still providing all of the information and what you need for your automation system. This is a fun one. In the life safety world, we are very code driven. If it's a fire alarm system, it has to meet NFPA. And your city state has most likely adopted an addition of the I codes. So which I code have you adopted? What are you running? What is it referencing? Keeping up with codes and standards is one of the biggest challenges we have. Technology is changing so fast. You'll find that a lot of your codes and standards are leaning towards frameworks, or they have a common phrase that states that nothing in the body of the code is meant to prohibit systems, devices, equipment of equal or greater quality from being used. There are a couple of standards out there that are worth looking at when it comes to smart buildings. ASHRAE 90.1 is an energy standard for buildings that would be worth looking at. Guideline 36 gives you your high performance sequences of operation. Within the VIXI world, 007 is their information communication technology design and implementation practices for intelligent buildings and premises. VIXI is very much a wiring and a cabling organization if you're not familiar with them. And this one does break down and refers you back to the appropriate ASHRAE, NFPA, CS standard when you get to the individual systems, but it talks about the overall, how do I integrate as part of the process. NFPA has a standard for integrated fire protection and life safety system testing. This is effectively a recommissioning type of standard, and it's now required in the 2021 IBC IFC. Calls for NFPA 4 recommissioning where you have smoke control or high-rise buildings. So think about your smart buildings. You have tenant retrofits going on. You really need to do some of this to make sure that the original sequences are still working, still operational. So these are just a few of them. And we'll see more popping up. So just keeping an eye on that, how they do this and what they're trying to do. So now we're getting into the smart building, the technology stack. And this is one of my favorite, this is a great way to show it. It's one of my favorite slides that we have. You know, we start from the bottom. This is the part we know about. This is the device layer. We have all of our devices, our inputs, our outputs, our panels, any kind of kiosk, graphics. Our individual systems are connected. Then we have the capability for the interconnectivity, any of the gateways you may have. This is your network layer. At the top, in the application layer, you have your cloud services. Yeah, this is what we refer to as part of the cloud. And this is where we are reviewing things. We're looking at it. How do we gather the information? You know, it's kind of a northbound perspective. They provide the flexibility, the adaptability, and the scalability. This is where some of your analytics, your visualization occurs. Now, I skipped over the middleware layer, because this is really where we are and what we're working on right now. When we get to the middleware layer, you could also call it the integration engine. This is where you're taking that real-time data and you're acting on it. You have a rules-based middleware that applies rules from a data set to execute logic across all building systems. Syntax abstracted and applied to all different languages, or protocols is another way to call these languages. So it can speak to all hardware. Some of your rules-based middleware functions include basic reporting, documentation, remote notification. So the newer part of this is your context-based. You could also call it semantic interoperability. And this is a little more advanced. You have an open source community that is looking at the metadata inside the data. So this is, how do I explain this? Take a cell phone, you take a picture of it. If you haven't turned, you take a picture with your cell phone, if you haven't turned the GIS off, that picture can give your exact geographical location. That geographical location is the equivalent of metadata that's within the data you're saving from a building. So this is a key challenge that we are all facing right now in the industry. You know, most device data lacks meaning. We pull alarms off. We're having a conversation over in NEMA about the term supervisory and trouble. They mean one thing for a fire alarm system. They mean something else for a sprinkler system. So at some point, we have to get these things consistent. And that's what's going on with some of the data sets. We're not just talking fire alarm. We're not just talking sprinkler. We're not just talking automation system. Think if you were to respond to a building, a hotel, what if you wanted to know which rooms were rented? You don't need to know who's in the rooms necessarily, because that gets into data privacy, but I need to know that X number of guest rooms are keyed that night, because they use keyed as a determination that it's rented. And then where they are. So you could be tying into a reservation system. You could be tying into a rental system. It all depends what you need for a particular use case. And as part of the context base, we're talking about tagging and creating a standardized method for describing and contextualizing the metadata, making it more human and machine accessible to analyze, visualize, and gain read value. So these are key of what we will see going forward. Any questions on this?
Right. You don't have any questions right now. I've got a lot of stuff I'm jotting down here.
Okay.
But do you want to go a little more into? Well, I think you're doing it, but drill down, because I think this is important to understand, or an area that, you know, I guess who owns this middleware layer? Is that vendor specific? Is it a mix? Who's working? Who are the people doing all this work?
Well, you know, the data comes with the system. This all goes back to who owns the panels and devices. And you think about the software that's in the system. Technically, the owner of the building owns the building system. But what if I'm pulling data from my cell phone? That's my data that maybe you're pulling through Verizon or AT&T. Or if you were responding to an event and somehow you got into the health part of a cell phone or a Fitbit or some kind of fitness tracker, just to understand where I have a heartbeat. So where do I have live people I need to go rescue, rather than, okay, that part of the building is on fire, I don't have any live heartbeats over there, I don't need to send anyone into that space. I do need to fight the fire, but I don't need to send someone over there. So in that case, think about it, it's blended, because the Fitbit data belongs, or the health data belongs to the person, and yet they're able to leverage it, which is why I made that difference when I said with hotel reservation, I don't need to know who it is. You have to separate out the privacy aspects. So it gets a little blurry at this point.
And we've got a question here. How regularly would these systems need to be maintained? I'm not quite sure which systems, but if you can take a swing at that one.
You know, that's a good question. I can tell you that your basic system maintenance requirements are not changing.
So some of that is standards driven. I think most of our core audience is familiar with the NFPA, but are there comparable, time intervals spelled out in the other parts of the smart building technology?
So when we are talking about how we do things, we have to look at how it's changed. And we have to understand how we are bringing a project together. It can't just be throwing everything out for bid and having individual disciplines bid it without coordinating. What does that lead it? It leads us to something along the lines of smart building, a new version of workflow. So think about bringing in a technology partner. Your technology partner is the one who's going to look at technology and what needs to be integrated and how we integrate it and when. Traditionally, they're bringing after the bid. It's a little too late because your individual disciplines have not included any integration in there. So now you're dealing with change orders to take things out or add things in. This is why you need to bring your technology partner in during the end of schematic design, so they can help with some of the design development, with some of the team project definition. They can also bring to light some of the integrations that will be used. What it also can do is raise the concept of how you would need to do this and when to buy things. So just a thought on that. Another.
Well, okay, I see you're going to expand on it, Mariah, but
go ahead.
As somebody who has worked as a, as an owner's rep and as a kind of an enforcer, this is a big change from kind of the way the industry has been set up for the most part, right?
It's a huge change.
Okay.
It's looking at it very differently. Your technology partner or integrator was typically a sub to your mechanical or electrical, if that much. They need to be up equal with them. They need to be working with the GC from day one. This is kind of a workflow process. You're going to bring them in on the strategy and visioning for pre-construction. So even where the GC is coming in through all of this, think about it. You have them there for project vision meeting, any site tours that you may have. There may be an NDA involved as they start looking at specific use cases and trying to help create a spec, which is what we call technology co-creation, because it's not your normal spec. It's geared towards a specific use case. Yes, you still have to meet all of the standard health and safety requirements. So anything you had from your NFPA 72, your fire alarm requirements, those aren't going away. Your building still has to be safe. You still need to meet those requirements. But we're looking at how we integrate the systems, and it becomes more of a use case, which gets back to how is the building being used. You're going to create your work blocks. We'll see those in the next slide. And provide, solution options, which leads to construction, where now you install, you build this and commission it. It's great to turn it over to the owner, but once you have a smart building, you have to keep operations and maintenance involved. You have to make sure that you are maintaining your building in order to keep meeting these requirements. Think about LEED. A LEED building, it's a green building, has to be recertified. Think about maintenance now as a recommissioning or a part of that step. And with technology, you may have to take a look at, do I have to update? Do I need to replace? Is there a better way to do it? So this is a little bit of an eye chart. What we've done is we've taken a little bit of a breakdown on each of the segments, starting with security, fire, automation, energy, lighting, your network, healthcare, mobile apps, concierge, management, transportation. All of these are part of the work breakdown structure. And then we've given them a key. What value do we want them to bring from technology? Let's keep in mind also, what problems are we looking to solve? Just because I can connect everything together, is it the right thing for that building, for that use case? And yeah, we can connect everything together under the sun, but is it the right, does it provide the right value, the most value with the budget and time allotted for that project? So these are some things you have to keep in mind as part of the design process. And that's where you have to get everyone involved as part of that, the owner, the architect, the technology consultant, the GC. And even once it's awarded, you bring in your vendors, your partners as well. It is a bit of a different structure because we start looking at what we call a Division 25 framework. One of the easiest ways to look at this, very simply, is it's integrated building management. It's an integration section of the specification section. It's going to refer you back to various parts of the specification, but it's also going to take into account a section that tells you, hi, I need to make sure I consider IP signage for integrated mass notification. I've got electrical power monitoring. I have building management systems. So you should have a construction team matrix. And this is something that really should be used as a way to create that functional specification. This is the systems and data architecture for a smart building. Did that answer your questions?
Here's I don't know if that it did, but there's a follow-up here on if a building, I think it's stepping back a little bit, but if a building's directed to have a level of initial acceptance testing, and that decision is identified early on in the building design process, has there been a better experience with coordination among the disciplines compared to when systems are accepted or commissioned individually?
If I understand it, if they are letting you know early in the design process what will be expected for the commissioning system, for the commissioning process, will that be a better experience? I would say yes. Think about If you're designing for healthcare, Joint Commission, if you know that you're going to have certain requirements and certain commissioning requirements, it's a lot better to know that up front.
Okay, we'll continue, and we'll probably go back up to the 10,000 foot level in a minute, but let's keep going, digging in here.
Not a problem. Which actually, that was a great question to ask, because now that leads you to commissioning and warranty. And this is something that's coming through. The last couple of years have brought in the concept of remote inspections and remote testing. There is a new standard in development for NFPA 915 that is focused on remote inspection and testing. It does not describe any of the actual tests that need to be done for commissioning or inspection. It doesn't talk about the time frame. It leaves that to the appropriate system, whether it's 13, 72, 70, whatever it is. NFPA 915 focuses on the mechanism for how do we do this remotely? How do we transmit the data? How do we protect the data and understand it so that we can accept it? Yeah, how do we store it? That's all it focuses on. But that's a great way to think about it. Are we doing it via cellular? Are we doing it video, drone, what? So this is some of the stuff that is coming up. We're starting to see things, I believe it's another manufacturer that has self-testing smoke detectors. Someone else can turn their notification appliances on. So you're going to start to see smart devices get even smarter. And how will these help? Little things to start thinking about. I would say the next step will be something like a digital twin. This could even go back up to that 10,000 foot level when we start talking about the design process. A digital twin is a virtual data model of the real physical building. The physical building produces data that feeds back into the virtual module. So the two are, they are always representative. Digital twin has been around for a while. It's not something new. It's what was used to create the Mars rover. So the concept of creating this digital object that will then become a physical object and running all my criteria through there, I could run smoke control calculations and see how the smoke movement's going to move and how my system's going to operate. I could run evacuation modeling. How do I get people out of the building or move them around the building? Now, from a maintenance perspective, I can start to use this of, okay, why am I using so much energy? Where is this breaking down? Aha, that's where I need to look at it this way. So this is something to think about as a next step. And how does it fit in? Well, it's really part of an evolution. It starts with BIM and BIM design. Your static model becomes enriched with live data and the building systems, because when you use BIM, you're putting in the BIM models for what is physically going into the building. Think of it from an energy perspective, that building twin as a feedback loop that continuously adjusts to the actual building conditions as they evolve over time. It will graduate from your construction model with all of the asset data, manuals, warranties, etc., to a more operationalized model that's using live data from systems, weather, and people, and how they're responding. You mentioned SFPE. The foundation has a study going on right now on BIM tools for the fire protection engineer. So that's bringing it down past the 2-inch conduit out to the device world is starting to think about that. This is coming. So as we go into some of the future trends and ongoing challenges, any other design and construction questions? Okay, I'm going to go into my design and construction here, or excuse me, I'm going to go into the future trends and ongoing challenges. Like anything, new technology, new trends provide challenges. There's always something, some oops we hadn't thought about. You know, now we need to take into account the tenants, the occupants, along with manufacturer, because everybody's involved when it comes to the design stage. And this creates a increase or a lack of representation and unified vision across the stakeholders during that design stage. So you've got to bring them in order to prevent adverse impacts on the final delivery. Cybersecurity. There are more devices than there are people. Attackers are growing in both numbers and sophistication. And with a convergence of IT and OT, you know, how do we do this? How do we protect against it? If you're following NFPA, you'll see that in NFPA 72, the 2022 edition, cybersecurity has been added. There's a new chapter 11 starting to address that, hey, this has to happen. But it's not just on the manufacturer side and making the product. It's not only the design and the installation or construction. You have to take into account, just because I can connect various systems together, is there a reason to do that? Or am I opening a door to something I don't need to do? You know, when I get into the construction side of it, oh, I need an extra cable here. I need to connect into the network. I can grab this network and I get back there. Well, is that the right one? Or are you opening the door? What are you doing with that? So it will impact there. We can do everything right when we turn the building over. The owner still needs to maintain it. Maintenance is going to be even more key. You have to make sure you're doing the patches. Probably the easiest protection for cybersecurity, password management, changing passwords or eliminating access if employees leave. So keeping on top of it is going to be key. Interoperability, not just about avoiding costs. It's also keeping in mind value. You know, just because we can be interoperable between systems and we think it's going to save costs, it's not what it's for. Why are you looking to have those systems interoperable? What's the value? What's the reason behind it? You know, just because it's the latest and greatest thing isn't always the best reason. You do need to start with the end in mind when you look at smart buildings in order to mitigate unnecessary complexity, which will also equate to significant cost. All the complexity is more costly. So these are a couple things to keep in mind. You're not looking to make it complex. You're actually looking to simplify, and sometimes that's more difficult. We looked at the design and the construction process. Think about that as a procurement. That's rather fragmented. You know, we're looking at single issues, single vendors, single silos, and not looking at an entire ecosystem of what works well together, what systems need to be networked, and how do we integrate. So that will cause you to look at procurement a little bit differently. It's really about collaboration. And it's about skills and training. You know, we see a difference. It's not white collar or blue collar anymore. It's that new collar, middle skills section of the economy. So we're looking to ensure that students are learning marketable skills, finding design curriculum that help them. There is a skill shortage, so you have a huge war for talent. And then you also have the aspect of, how do students get the job skills? How do they learn? Apprenticeship models are one way, on-the-job training, doing cohort type programs that allow them to gain a college degree or the educational that they need while working in the process so that they're debt free and can take on these jobs. Living labs. Sometimes the buildings, university buildings themselves, become part of the lab. So what's next? You know, what do we expect in the next 5 to 10 years? Well, for one is regulation. Regulation and adoption of building codes and standards, credentialing bodies, changes that we'll see in that. There's an uptick in frameworks, specifically towards smart buildings. I think we'll probably see more of this because it becomes a case of it depends. It's all about the use cases. So until we can get standard use cases that mesh with the way we look at occupants, you're going to see these frameworks appearing. You also have the prioritization of experience. You know, people want to be well. How does the building help them perform better, heal, learn, all of this? Emerging technologies. You know, where we see this, market adoption can be broken down into 5 phases. So it starts as a trigger. There's a peak of inflated expectations, a dip down because, oh, wait, it's not doing what I thought it would. Then it starts gradually growing back up as it's adopted. So we're going to see over the next 5 to 10 years, smart buildings progress towards that final phase of mainstream widespread adoption. We talked a little bit about metadata and data information. There needs to be some kind of standardization on that metadata. Otherwise, it's going to be difficult to implement smart buildings at scale. You know, how will we develop data interoperability standards? That's towards the metadata that we're talking about. You know, I think we'll see some of that coming through. IEEE is a big player in that one. AI is going to play a factor when it comes to filtering some of the data. That's really where AI is going to help us to help filter it, because you will have such sheer quantities. We're going to need machine learning and artificial intelligence to bring it together. And then consolidation. You know, there is an increased merger and acquisition. You could think of that as a sign of industry maturation. And this will be good for a lot of people, because if once you bring it together as consolidation, that also adds to the trends of, okay, this is acceptable. It's not just a startup here, a startup there. Is it going to be around in 5 years? Am I going to put something that is a startup in my building, physically in my building, that I expect to survive? These are just a few of the trends. I would argue some of the green and the other data will play a factor. We're seeing EPR bills, and there's a lot of talk of e-labeling. So many of the booklets that you have won't be there. It'll all be electronic. Use cases. We're going to start with.
Hold on.
Okay.
We had a question that I've been holding. Before we get into this, could we talk about in the big picture how smart buildings, the role they play in terms of getting to reduction in carbon or carbon neutrality?
Yeah, it's a very good question. We talked about the 2030 challenge for the architect. Think about the materials that are used. For one, you see a lot of tall wood timber or timber buildings. There is talk of low carbon concrete. There is electrification, which is bringing in all of your EV charging. Now you start using microgrid. Can the building generate its own energy? Solar, EV charging. Can it become carbon neutral in that sense, or energy neutral? So there are a lot of different ways that it can do it. And there's a lot of different ways that we can bring in decarbonization to track it. And that's where some of the smart building may play a factor. The design will definitely play a factor. The other thing to be aware of is, just because you're doing a microgrid, do you have energy storage systems? What are your potential hazard risks? Not sure if I answered it. I think I was kind of circular there.
Well, I think the play is I guess being more energy efficient and over the life of the building as well, yep. Right? Okay.
Yes.
Okay, I think we covered it.
Okay. So let's take a look at an office building. Think about it. We're going to go back to, we're still going into the building. Wake up in the morning, you're driving in, tells you the fastest way to go. So you're using your cell phone based on where you want to go. You get to your building, your parking spot is reserved, and access is based on your license plate or a QR code you may have on your badge. Tells you where to park. You've parked your car, you're ready to go into the building. Your access key card is via your smartphone. Potentially your building uses hoteling, so it tells you, okay, you're at this office space or this desk space today. Great. By the way, your colleagues and you're in space 30, they're in 32 and 34 if you're looking for them. So not only does it tell you where you are, but where they are. You can use a room reservation seamlessly, goes into your calendar, lets other people know who may be on that meeting, they can join in. Okay, think health, wellness. You want to order lunch, links right to the restaurant there. You can link into other things. So not only does it tell you your desk or your office, but perhaps it knows that you prefer a cooler workspace. It's learned over the years that, okay, you like the temperature at 68, not 70. And the lighting can go all the way up, or maybe I want it dim. So it'll set the workspace by the time you get up there. You can use your phone to report any issues. Receive notifications, and then when you're ready to leave, here's the fastest route home. You're basically making the building work for you as the occupant. By doing this, think about it. The building isn't trying to cool every office space down to 68. And it doesn't need to keep your space cooled until you get there. So now I can start saving energy. I don't have to have the lights on because you're not in the building. Do that times 100. Think about the energy you could save by not having to have it on 8 a.m. till 5 p.m. Healthcare. You know, this one, big thing, big push for healthcare is to prevent HAIs, which are healthcare infections, healthcare acquired infections, excuse me, or hospital acquired infections. You're also looking to improve patient satisfaction and to send them home as fast as possible. So how do we do this? Start with the patient. How do you find where you're going? Having spent a fair amount of time in a hospital earlier this year when my father had a heart attack, trying to find my way around an unfamiliar hospital was very challenging. The wayfinding app was great. It got me right to the ICU where he was. He's home, by the way. No worries there. We didn't have to worry about virtual visits. We were able to attend personally. You know, the smart room controls, setting it up for him, perfect to have. What we've also learned with those smart room controls is we know through studies that certain operations, such as a transplant, the patient heals faster if the temperature is kept cooler. So you can automatically set the room based on the procedure. Again, notice I'm not saying the patient name, I'm just saying procedure. Transplant. I set the temperature for the room based on transplant, not based on Mr. Jones. Which leads me into the doctors and nurses. They're very worried about infection control. What if I knew that the room was unoccupied? Now I have an opportunity to go in and do all the deep cleaning I need to. Patient monitoring devices, you know, fall alert, other sensors that you may have in there. Care interaction monitoring. Video boards. Any of those things. You could have the remote that they use, Sonicare, which is telephone as well as call button as well as TV remote. Could also be a question, how are you feeling today? What would you like to order for lunch? You know, your choice is sandwich or soup or spaghetti, whatever it may be. Push A, B, or C on the remote. So now you have the care interaction, which also leads you to, presumably, to improved patient satisfaction. From an administrative perspective, if I can turn the beds faster, presumably my patients are healing relatively quickly. I am not keeping them in there. It's also a little bit of asset management. It's amazing that things like crash carts and wheelchairs develop legs and wander off. Now I can start tracking those and see where those are. It helps me understand how to communicate with my personnel, what information they need. So these are just a few of the things that you can think about. Just ways that you can start linking it together. You know, think about integrating Purell hand sanitizer stations with Wi-Fi for proactive maintenance. Think about a glass touch screen that allows you to provide information at the nurse's station that can easily be cleaned in case of HAIs, those hospital-acquired infections I mentioned. Air travel. We have a couple of different sections on the air travel. You've got what's open to the public, and then with staff. So we'll look at a couple of challenges. Smart washroom monitoring. How do you maintain a level of comfort and hygiene? All airport facilities during peak and non-peak. You can identify hot spots with sensor technology and activate staff or send them to those areas based on traffic or frequency of use. You know, washrooms are key triggers for passenger satisfaction in many airports. So monitoring and billing for ground power units, GPUs, and preconditioned air units. Your aircraft uses its own power when parked, which is wasted energy and a negative environmental impact. PCUs and GPUs, or PCAs and GPUs, are required to allow the aircraft to shut down their auxiliary power units. Systems are often standalone and not monitored. Airlines will pay the same for a service to the Airbus A320 and A380s, as the actual energy consumption is not monitored. But what if you could monitor it? And then you can actually pay just what you use. So now you're getting into metering, and you're paying just what you're using. This may lead to a little bit more energy cost savings, as well as a better experience on the airline side. Emergency communication and messaging. Airports tend to have a very diverse population, dynamic and expansive environment, movement of people, all directions, and many different stakeholders, as well as many different AHJs, from facility management to TSA, border control, customs. So how do you solve that? Leverage different modalities. You have paging, you have gate signboards. Your advertising these days tend to be digital and switching ads. Well, put messaging there. Think about it. Not all of your visitors in an airport speak English or understand English. How can we provide it in different languages in a way they can find that? Also, understanding how you move people. If you have a flight from overseas that has not gone through customs, you can't put them out on the tarmac. They can't exit the building automatically in case of a fire, because this puts them against our border patrol laws. So where do we move people in case of a fire? Having those maps done and routing set to send them there. Just a couple of the things that you might do. Asset tracking is big here. Think about missing, lost equipment, looking for things, wheelchairs, AEDs, all of these. You can do it with Bluetooth, other technologies as well. Laboratories. Here you've got advanced user HMIs with their dashboards and mobile apps. Labs are unique in many ways. Real-time feedback on air quality, critical. Think about your air changes per hour. Smart buildings can incorporate a multitude of advanced mobile-based, web-based, room-level visualization and alarms. So these are something to think about. Your advanced demand control ventilation can also leverage the interconnectivity and intelligent indoor environmental quality data analytics to respond, anticipate, document, and visualize not only IEQ, but energy use, flow data, and more. You have room and lab level integration. This includes lighting, shading, HVAC, can help save energy, give you greater productivity gains, and increased flexibility. So think about a lab where you may be in there when you're running an experiment. It may be in 9 to 5. You may be in there 24 hours. Allowing this to be used when you're in the space helps with that energy saving that we talked about. In addition, real-time location service, or RTLS, is also good. That allows you to keep an eye on where your critical assets are. And, what do I need? Where did it go? Hazards. Fire suppression systems and fume hoods, clean agent suppression. These can be very challenging. You have a unique risk with critical room pressurization, and ensure that you have the right data, the right actuators. Everything is still integrated in operation. So just a couple of the things there. One last use case here. Smart buildings for learning. Think about, the first thing that comes to mind with a campus is going to be, unfortunately, emergency communications. You need to be able to reach faculty, students, staff, anytime, anywhere. You can have an automated response that can be activated via GUI or a single login with the appropriate credentials. Could be integrated between mass notification and room automation so that your shades and lights throughout the facility could be turned off to provide, or on, to provide visibility from the outside for first responders. How do you learn and anticipate changes in demand based on user occupancy? You're going to fill potentially a large assembly or a gym quickly. How do you leverage that data so that you start maintaining the comfortable temperature, humidity, and ventilation that's needed, but not 100% of the time? That room doesn't need to be ice cold when no one's in it. So how do I leverage a sensor showing me that data? One of the biggest opportunities for smart buildings in the school and campus environment is the living learning laboratory concept, where the building becomes an immersive learning tool and is using this whole co-creation approach. So what you allow the students to do, you may have dynamically controlled systems such as rainwater collection, solar, green rooftops, advanced shading and lighting, occupancy, security, and fire. And you allow the students to participate in hands-on research and development of emerging technology. We've had a couple of universities that we've worked with that have done this and allowed the students the opportunity to do projects on their own building. So these are all a few of them that you can do, or some of the use cases that we've seen. As we look at a summary, the biggest one is to start with the why. You need to focus on what the outcome is. How is this building going to be used? Don't focus on the features. Think about how you're going to use the building. I would recommend a proof of concept pilot. This is where you scale it down. It's a phased approach that gives a chance to get started, to try it out. Advocate for an integrated team approach. Everyone needs to be a part of the team for this. Collaboration is really the name of the game. And with that is develop a technology roadmap. Just because it's the latest, greatest thing, is that really the right widget to use? Smart building technology is modular and extensible. Think about building blocks. So it can be aligned with budgets and construction timelines. Consider phasing in technology over time. Consider piloting some of the technology in pieces or phases through testbed or innovation center approaches. But if you do it with a roadmap, keeping that outcomes-based why in mind, that allows you to understand how you're using the technology, which will really mean that that roadmap is much better. The other change through all of this that I hope you've picked up on is design and build for tomorrow, for today, not for the moment I turn it over and then I'm done, I'm off to the next one. Think about how you're using that building. Incorporate design and construction features that enable progressive incorporation of technology during, not only through the design and construction, but throughout the operation and maintenance. You may have additional sensors now, but understand how and what you're doing with them. Protect against value engineering. Smart building features are often misunderstood from a value perspective and an outcome perspective. So frequently that integration is pulled out when it comes a value engineering topic. So you need to understand what the implications are when you start piecemealing building technology through value engineering. Get involved with a technology partner early. You know, if you're going to use Div 25, you need a technology partner early on. Include the owner operators, AHJs, and occupants when possible during the planning. You know, one thing we've been saying is that a smart building is an extension of its users, operators, and the AHJs. You know, we hope that you're not called to it other than the initial commissioning, but you need to be involved so that you're aware of it. And your vision should be driving the technology rather than the technology driving us or you. Design and implement virtual facilities management plan. You know, look at how you're going to do this. There has to be continuous maintenance. You have to look at predictive maintenance, machine learning. Make sure that everyone involved with the project understands that one of the core elements of a smart building is its continuous maintenance. Qualify and quantify. The first cost of non-traditional smart building technology is always, you know, by considering that long-term value and outcomes. Don't look at my upfront cost for the life cycle value. The operational cost of a building during its life cycle is typically around 10 times the cost of its design and construction. So make sure that you have everything considered as part of this. And as we said, please take a look at the concept, you know, the idea of a proof of concept approach. You know, it's a great way to leverage this and to try things out. You're starting with a why. Sometimes you need to test it out. Try a proof of concept if that really is what you wanted to do. And with that, how are we on questions and answers? Any more questions?
No, I'm going to put out another call here. This is our last round of questions. I do have a question here on where do you see things going now? You mentioned AR, augmented reality, and virtual reality early on in the talk. Is any of that, at what phases is that being integrated, or is that still kind of in development?
You know, I think it's where I've seen it have been with things like training, to give people an opportunity to do hands-on when it comes to training, at least from a virtual perspective, rather than actually activating all of the bells and whistles and evacuating your colleagues. I see it in that sense. I see it as being a great part of the design aspect. This is a chance to walk through it and see what it's going to look like from a design perspective. Put yourself in that space. Now I see, oh yeah, this is what it looks like.
And when you talked about interoperability, right now each vendor, in terms of they integrate systems within a building or within a project, and their systems don't necessarily interoperate with other vendors or other manufacturer systems, right?
There are two types of things. I would say most manufacturers can provide a data stream or a network interface to another manufacturer for a read-only type of situation. For example, I've done a network interface for smoke control, providing the read-only data to a JCI automation system. So they could then activate the smoke control, dampers, actuators, everything that needed to be done. That's a one-way communication. A two-way communication, I can do Siemens to Siemens. Because it's our system, it's easier for us to get through UL listings and have that two-way gateway. some of the interoperability in that sense, if it's a one-way data stream or overlay, that's there right now, and that's not a challenge. It's when you get into proprietary programming that and UL compatibility where we have some of the limitations in the fire alarm side.
Okay, and then
but we've always
yep.
had interoperable systems.
Okay, all right, thank you for that. And then with regard to the fire alarm, you know, the fire alarm is as it exists today, pretty much you know, kind of a 19th or early 20th century concept in terms of the technology and the way that it's designed to work. You know, and that a device either goes into alarm or is not an alarm, and once it's an alarm, you know, it locks into alarm, and then a responsible party has to come and reset the device. Where do you see kind of the traditional fire alarm going in the future in light of all the advances that we have in sensors and this technology?
I see our detection sensors growing in, I'm going to call them use cases. It's already in existence, and we already have application-specific algorithms that tell us based on what's in the space what burns. So we have multi-criteria detectors that are available on the market now. I see more multi-criteria detection out there. I see detectors that are capable of providing more information and data, or picking up, or is fire alarm systems picking up data from other sensors and other sources that may be out there, based on that, making a determination of what action to take. Fire alarm, because life safety is involved, and that's risk and liability, will always have some semblance of, if I'm in alarm, I need to look into alarm until it's reviewed. I don't know that that's going to change in the short term until we address the liability aspect.
Okay, well, those are all. I mean, these are big issues. What's your feeling in terms of the industry? And really, this goes way beyond. You talk about, you know, liability being a big concern to the wider adoption of this, or getting it beyond kind of the, you know, getting into the life safety pieces, which are most interest to the first responder community. You know, that implies, you know, lawyers and legal and risk people, which are traditionally not, you know, considered in the building architectural engineering space. And are those professional communities being engaged in this, or how is that happening?
Well, insurance is definitely involved. So risk is definitely involved. Think about it. You have the fire protection engineer involved. Part of what they do with the design is based on the hazard and the risk analysis for the building. And that really plays into the design factor. So it's already there and already engaged. You know, I think my personal 2 cents, this is me personally thinking, I think we're going to see some changes in building systems and leveraging more data and other systems. The catch will be, we have to find a way to balance data privacy and safety. And once we do that, I think we will have a lot more information at our hands, possibly more than we may know what to do with. So I would urge caution on just jumping full force in. If you saw the amount of traffic, think about the amount of traffic that goes across a security system, card access, especially in the morning when folks are badging into a building. It could be very easy to miss a crucial part. So this is where we're going to have to leverage machine learning or artificial intelligence to help filter out or to catch key data points.
Okay, so last call for questions. And then if for people who are interested in learning more, where's a good place to go to send people to get some more details on all the various things that are swept up in this topic?
Let's see, the Continental Automated Building Association is a good place to go. I would say we could always connect you to the NEMA High Performance Building Council is another one.
I'm gonna go ahead. I'm gonna preempt Maria, and because I can see people. I can't write it down. I know they can't. So I'm gonna strong arm you for a follow-up reading list or organizations, which I can then circulate to the attendees,
Perfect.
which I think will be really great. So last call on questions. This is your chance. You've got a real expert on the line here. Somebody's got a really good understanding of such a big and important area that we all are going to be impacted by. I'll give you a few seconds here for that. Any questions? Don't be shy. Just real quickly, in terms of the education challenges, let's talk. Probably we're most familiar with the fire protection engineering community. So what is that looking like now? So this has made its way into the engineering curricula, and people are coming through kind of aware of these technologies and working now in design with building information models and digital twins and all these things.
All of those have come in. They've come in as separate systems.
Mm-hmm.
In terms of calling it a smart building, that is still coming. You know, as I said, there's no one definition. I think I started everything by saying that. What we are looking at doing is, however, how do we define those use cases? How do we ensure that we are providing the data when we need it, how we need it, to who needs it? There is a work group that is looking at a proposal for the I-codes that will reference a couple of the building frameworks, wired, score, well buildings, and LEED. It's really looking at it more from an energy saving perspective of how you get there. You know, I think in terms of training, there's a lot out there. There's a lot of new technology, a lot of things shifting and changing.
Okay. All right. Well, Mariah, I think the sign of any good topic is that you leave them wanting more, and this is such a big subject area, and there's so much here. I know, you know, because I try to stay up with this, and we've done some work peripheral, but I can assure you that there's people here just like me are kind of, you know, pushed back from the screen, and the wheels are turning, trying to take this all in. So I want to thank you for presenting for us and for sharing the information. And you know, we'll certainly stay in touch, and we'll be looking forward to the follow-up, and we may have you back in a few years, and we look forward to all the developments. Is there anything we can be doing as professionals and sympathetic consumers in the building safety and public safety realm to help push this effort along?
I would say keep a couple things in mind. One, collaboration, and two, why. It all comes back to what are you trying to do and why. If you understand that, then there's a reason or a way to find a path forward.
Okay. Well, I think that's a great place to end it. And so to all of our attendees, thank you very much. And Ryan, once again, to our presenter, thank you. And a reminder, our final presentation for the semester will be on May the 2nd. We'll have Bob Hennelly, the journalist and writer, to talk about the politics of public safety in New York City, which should be a fun topic and certainly plenty to discuss. So thank you all very much. Bye-bye.